So let's have a look at these examples that I wrote. I think they're pretty good examples to illustrate and they're good questions. So example 8, you've got triangle ABC, PQ bisects A, B, and C. So that means this line cuts this length into 2 equal parts. Same for the other side. Prove that PQ is parallel to that, and this is half that length. Obviously, it doesn't look like it on my diagram, but we need to prove it. Okay? So with this type of questions, the first technique in using vectors to prove this is actually label or make up vectors yourself. So to start it off, let's say, why don't we let this line, or it doesn't really matter at this point where you direct it. Let's say that's vector W. Okay. Actually, let me not give an arrow for now. Let's just, if that's W, then this also must be W, right? And give it another vector for the other side as well. Let's call that V, and let's call that V. So that's like your first thing that you want to do when it comes to proving vectors without any actual vectors given to you. Once you've got that, let's have a look at the question again. Prove that PQ is parallel to BC. Okay, so basically we need to then look at that, and then look at that. So what do you think? Let's look at the two triangles separately. Right, so we got PQ, and then, oh hi Husna. And then we got big triangle BC. What can we do here? Let's not think about the question. Let's form vectors out of the triangles that we've drawn. Right? So this is what we have so far. Yeah? What's this though? 2B, 2W. That's right. All right. Let's keep going. If I want PQ, if I want that, then what direction does V have to be? So it's like northeast. So north, east. So from the state. Is that correct? Yeah. Yeah. Does that flow? Yeah. Yeah. So PQ is equal to. Okay. Similarly, if I want BC, because remember that's the question, prove PQ is parallel to BC, then I need that to be in that direction. So north, east. So this is, yeah, and as you can see, in order to prove two vectors are parallel, what do I need to do from your assessment task, Kylie? Factorize it, yeah? She added it wrong. Yeah, so as you can see, because this is the same as PQ and it's a scalar there, those two are parallel. So we've done that. Therefore, parallel. Write it properly out in your exam, but you get my point. That's the first part of the question. And the second part of the question, what does it say? We've already done that as well. How does this fact prove that this is half its length? Well, as you can see, the vector is twice that. Yeah? And twice PQ. All right, so I don't need to do anything separate, so that's how you do it. Okay? It's not hard. It's tricky when the vectors aren't given to you. Okay? Similarly, for question 8b, 8b has nothing to do with this. It's a separate question on its own. Prove that the diagonals of parallelogram bisect each other. That's all it says. No diagram, no vectors. What do you do? Well, this is like a starting point to help you out. You draw the parallelogram, label the corners, and then because we're trying to prove that the diagonals bisect each other, going back to our junior properties, what that means is prove that, that's what they want us to prove. Prove that the diagonals cut the length of each other of the diagonals in half. This is actually a tricky question. It actually took me quite a bit to get it. So here's how you prove it. So NTP, need to prove. Would you agree this would be a way to prove it? Because you're looking at it this way, and then you're looking at it this way. But in terms of the vector, it's actually not that easy to see what to do. So in terms of vector, i.e., what you want to do, so that, and then find sides, P and C. Okay, so if we get the same expression for OP from this side of the triangle and same expression for OP from this side of the triangle, okay, can you see how that proves that the midpoints basically they intersect the same point? Is that right? So we're looking at OP from this. We're comparing the blue, getting the OP line from the blue line, but OP also from this line. So we're getting the same expression OP, that point, from two different triangles or angles because they intersect each other and they bisect each other. So if we get the same expression for OP from both sides, then that means they intersect at the same point, which means the midpoint of OB and AC is the same point. Is that logical? Is that okay with you girls? Yep. So let's do it. So let's look at the blue side of the triangle. Once again, there are no vectors given whatsoever. This is where you make up your own vector. So what I've done was, let's label this side. I'm going to point the arrow that way, A. Then opposite, can you agree that's the same? Because opposite sides are parallel and equal to each other over parallelogram. Similarly, let's give a letter for this side, and that will be the same for this side as well. Let's work with those vectors. So let's look at the triangle over here. We've got A, we've got B. So what I'm trying to do is I'm trying to get the expression for vector OB, so this whole thing. Because if I get the vector for the whole thing, then OP is just half of that. So what is this then? Does it work out? Northeast? Northeast? Yep, so therefore, OP is half of that. Okay, so that's all right. This is the tricky part. So what we're trying to essentially do is get an expression for vector OP, and it should be the same as that. All right. Well, let's do the same thing. Let's get an expression for AC this way. I mean, it doesn't matter if you go the other way, but just doing that now. So we've got, right now we've got A and we've got B. I need an expression for AC. Does it work out? Yeah, it doesn't work out. So I flipped this one. So if I point the arrow this way, then this would be minus. Does that work out? North, east, northeast. Does that make sense? So this is minus A plus B, but I'm going to write it this way because usually I write it the other way around. Okay, now, so we've just proven this thing to be that. Now from here, what you now want to do is now look at the bottom triangle here. I'll cut it out here. So right now I have, now remember this is half of B minus A. I have B right now here. I need OP. Now this is the part I want you girls to think about it. How do I get an expression for OP here? And this is the part I made a lot of silly errors. So just be careful, just tell me the expression.
B minus half.
Is it B minus half? So the other way?
Yeah.
Okay, if it's the other way, I'll put a minus there. Does that work out?
Yeah.
Okay, north, east, northeast. Okay, so OP is equal to B minus half. Yep, that's good. Now as you can see, can you see that 1 take away half is half for B. This one, minus times minus becomes, yeah, so as you can see, that's this, and they're the same. Yeah. Okay, it's equal. So yeah, that's basically how you prove diagonals bisect each other in a parallelogram. Okay, let's have a look at question 11. That's a good question from Maths in Focus. I'll just flip the page. Prove that CB and AB So CB and AB are perpendicular, so we need to prove that they make a right angle. So remember, if I want to prove two vectors are perpendicular, we want to prove CB, dot product of CB and AB is equal to 0. All right. Once again, no vectors given whatsoever, no letters, make up your own letters. That's the first thing you want to do to start it off. Now the tricky thing with this one though is because it's a circle, you want to actually start by labeling this vector to be some random vector. Let's call it, I don't know, let's call it A. That's the first step that most students won't be able to see unless they've seen this question. And what you actually want to do is you want to actually separate this triangle into two, like this, because we want to try and get an expression for AB. Let's call that B, okay? We're focusing on AB here. We're trying to get AB from this set of diagram that I have. So I'm trying to find this right now. AB. So how do I find this? Yeah, is it? So this way? Yeah, northeast, okay. So yep, AB is equal to, minus, or just, yeah, is that correct? Yeah. Now, let's look at this side here. Let's look at this triangle here. Now, this vector, girls, if I drew it this way, what will it be? I mean, I can draw it, yeah, it will be minus 8. Does that make sense? It's just the opposite direction. All right, so we're trying to get CB. So let's draw the triangle out separately. Does it work out or not? What do I need to flip this one? Northeast. Okay, all right, let's just go with it. All right, assuming this is all correct so far, and that's correct. All right, so let's take these two. We've got A plus B, dot product of B minus A. Let's expand it out. That's A, B. Those two are gone. So what I have is, it's a dot product. This. Now, obviously that doesn't equal to 0. But there is one little fact from the circle that we can use to show that this is equal to 0. What do you think? Going back to unit vector property. All right, from here, from our situation, what could you tell me about the magnitude of A? Yeah. So that means this is equal to minus, well, I'm putting in this form first. That. But that is the same. Can I write this? Yeah. And what's that?
0.
Yeah, that's what we want. So that's how you prove this. Okay, it's a good question. So in fact, this is the property in circle geometry. Circle geometry is out of the syllabus, but you do know to need this fact, and I'll write it now. Okay, so for question 4, assuming we know that, this is where the right angle will be. Okay, semicircle always makes a right angle within the circle. Let's have a look at question 4 from Fitzpatrick now. I don't know what the question is. From there, they want you to choose which one of them are true. It's a good type of exam question. All right, so they want us to work with dot product. Well, what could we do here? Whenever you get a question like this, it seems a bit incomplete, right? Take the triangle out. Ooh, what would that whole thing be? That whole thing. If I want it in this direction still. What's that whole? Sorry? Yeah, 2A. Yeah, because it's the same radius, yeah? So you know what? That's missing. Why don't we figure it out? What is it? Using vector addition. North, east. This must be then. Is this correct? All right, we've got that. Let's use that fact. That's like your key point. Perpendicular. Yeah? Which means, what am I writing? Dot product of. That's right. yeah, is equal to 0. And yeah, and can you see how they, yeah, so as you can see, that's the answer. Bring it to the other side. Yeah. Okay, so that's how you get it. So when it comes to any right angles, use dot product. The others, I'll let you guys figure it out why it's not. Your exercise. Okay, so those are the most questions I want to go through. I just have maybe little few touch-up questions I want to touch upon, but nothing in depth. So take a photo of that. I didn't know this plus this plus this is equal to that whole thing. Yeah, so it's just an extra little fact. Okay, so it's not just triangles. Yeah, as long as the arrows all go in one direction and it meets at the same point, you can add them up and it's equal to that. Okay, that's what I want to show. Now, question 7 is also a good little thing. Sorry? Yeah, so what that means is you could basically say this is 5 and this is 3. Now, the reason why this is useful is they've given you more facts. Hold on, what else have they given you?
And then A, B is A.
Okay. Just that. So in other words, like I've drawn the whole diagram here. Okay, so the reason why the ratios are useful is, you know how BD, what's it equal to? Oh, I need to flip it around, don't I? So then if I want to get BD, that's this, northeast. So that, yeah? Now, the ratios are useful because if I want an expression for, let's say, BF, is that what they want? Doesn't matter. It's that whole length, but what do you think I need to multiply by, given the ratio? So I just want this bit. 5 out of what, though? The whole thing is? Yeah. So that's where you use the ratio. Okay? That's all I want to point out. Okay, thanks, girls.